In an imaginary e-commerce company, GE Logistics, the lease for its current sort center is expiring. After much shortlisting, the procurement department of GE Logistics has shortlisted 4 candidate locations for consideration. For the first part of the analysis of the suitability of the location, you are required to conduct a weighted average distance analysis of these 4 candidates to the surrounding hubs which it potentially serves. The coverage area of this case study is located in Klang Valley, which encompasses Greater Kuala Lumpur. Wikipedia describes Klang Valley as the Klang Valley is geographically delineated by the Titiwangsa Mountains to the north and east and the Strait of Malacca to the west. It extends to Raong in the northwest, Seminyak in the southeast, and Klang and Port Klang in the southwest. The conurbation is the heartland of Malaysia's industry and commerce. The black triangle represents the hubs, whereas the red triangle represents the sort candidates. Hello, let's talk about the data you'll be working with. You are provided with 2 different shapefiles to kickstart your analysis. The first one is named sort_candidate shapefile, which contains 4 locations that have been shortlisted as potential new sorting centers. The second shapefile is named hubs shapefile, and it gives us information about existing hubs. Specifically, each record in hubs shapefile contains 2 essential fields. Hub_name, this field holds the name of the hub, so you know exactly which location you are analyzing. Volume, this represents the average daily volume of parcels that are delivered from each hub. This data point is crucial for understanding the workload and capacity of each hub. Using these 2 shapefiles, you can perform various types of analyses such as finding the optimal locations for new sorting centers based on proximity to existing hubs and analyzing the throughput of each hub in relation to the candidate sorting centers. In this next section, our GIS expert, Mr. Daniel Wong, will demonstrate how to add the hub and sort center shapefiles into QGIS.
Okay, so the way to add in the shapefile layers is through layer, add vector layer, and we look through hubs, just double click, and as well we need the sort candidate shape candidates as well. So once you select double click both on the map, we can format the shape a bit. I would like to make it a triangle. Okay, black triangle. For the hubs, I would like to copy the same style as well. So I'll copy the style to the hubs. For the sort candidates, I'll make it red. Okay, so now you have it. It is the black triangles as hub as and the red triangles as your sort candidates. Okay, so now we have all the hubs and sort candidate layer on the map. So the next thing we do is to run the distance nearest line distance to hub function. So we press Ctrl Alternate T, which will call our processing toolbox. We search for we can just search for hub, and this is the function that we want to run. And under the source point layer, we will select the hubs, and destination hub layer, we will select the sort candidates. Measurement unit we'll put to kilometers, and we just create save it to file as a CSV. We name it sort to hub distance. So in the data folder, save it. Okay, and we uncheck this because we don't want this layer, don't want the CSV file to appear on the map. And we select this iteration. So it will iterate, all the hubs will iterate to each of the sort candidates to give you the distance of uh, each route. Then you click run. Okay, so once it's run, if you look at the data now, you will see that the hub candidate the CSV file will contain the distance from each hub to the sort candidates, and you will notice here the hub distance of each hub to the each sort candidate. All right, so from here you will see four distance mapping for each hub to each sort candidate 0, 2, 3.
Hello, and welcome back to our Udemy course on data analysis for the logistic transport industry. In today's lesson, we're taking a deep dive into a powerful script that will help us calculate the weighted average distance from our QGIS CSV output in our last lesson. This script is an excellent example of how to apply data manipulation and analytics in a logistics setting. Let's break down the code piece by piece. First off, we load three essential packages: read for reading CSV files, dplyr for data manipulation, and tidyr for data cleaning. If you haven't installed these packages, make sure to do so before running the script. Next, we create a character vector named files that stores the file paths for all the CSV files we'll be analyzing. These files contain distance and volume data related to various hubs. Here, we define a custom function called calculate_weighted_average_distance. This function does two key things. It reads a CSV file and stores it in a data frame named data. It calculates the weighted average distance for each hub using dplyr. It groups the data by hub name, multiplies volume by hub dst, and then divides it by the total volume for each hub. The result is stored in a new data frame called weighted_average_distance. After defining the function, we use Laply to apply this function to each file path in our files list. The results are then combined into one big data frame using bind_rows. We also add a new column named file_id to keep track of which file each record comes from. Lastly, we print out the combined results so you can see the weighted average distances for each hub across all files. And there you have it, a fully functional R script to optimize your hub locations based on distance and volume data. I hope you find this lesson valuable. In our next module, we'll cover how to visualize these results in QGIS. Stay tuned and happy coding. In the resources section, you will be able to find the QGIS CSV output from the nearest distance hub function, as well as the full script.